Right, so polio status, and then whether or not they wound up with polio, no, yes. And then over here are our rows. We're going to give the title vaccine group. So we got the vaccine or the placebo. And based on the flow chart above, we can fill in some of the information. What can we fill in here? Based on this information here. Okay, good. So where would that go?
Across the vaccine, how many were? 50,000 in the total?
The 200,745?
Yeah.
Good. So the total, 200,745. Likewise, the placebo, the 201,229. So that's given information. What other given information could we go ahead and fill in?
The total amount of people who got it.
The total amount who got it, yes. So how many that were vaccinated wound up with polio? 82, good. And placebo then would be 162. And then from here, you can fill in the rest, pretty simply. So go ahead and use your calculator and try and fill in the rest of the table. Raise your hand when you have a blank to fill in. Kenzie?
And then no, and it's the vaccine. 200,663.
Good. And you got that how?
The total minus the yeses.
Good. And similarly, for the placebo, those given the placebo, the number that did not end up with polio, what did you get for that one, Kyle?
201,067.
Good. And then our totals are pretty simple. We just add those up. So along the bottom row, what did you get, Gigi, for the total with no? 730, good. And yes? 244. And total?
401,970.
Excellent, thanks. So there's a contingency table. The basics, just filling it in. And flip your notes over. We have up until this point, we focused on one variable data, which is also known as univariate data. Today we discussed the need for a new method to display data from two variables, also known as bivariate data. Hopefully that reminds you of a song. Yes, scatterplot. Scatterplots are bivariate. What? From bivariate data. That was my song that I sang you long ago. All right, make observations about the contingency table right here, 4.6. We've got all the faculty members at a college and their positions and their ages. So looking at the upper left cell, we find that there are 2 faculty members that are full professors under the age of 30. It's like a scavenger hunt. It's just making sure you carefully look for the correct value. So then the cell diagonally below and to the right of the upper left cell shows that 170 faculty members are blank professors, associate, good, in their 30s. We can just say in their 30s. And then the first row total reveals that 68, or you can add them all up, 68 of the faculty members are under the age of 30. Similarly, the third column total shows that 320 of the faculty members are assistant professors. And the number blank in the lower right corner gives the total number of faculty. Good, 1,164. And the total can be found by summing the row totals, so you can add these all up and they would add up to 1,164, or all the column totals. Sorry, these would be the row totals, these would be the column totals. Adding these all up gets 1,164, adding these all up gets 1,164, or adding all the cells within the table would also give you 1,164. It just depends on what information is already given. Sometimes there's not a row for totals, and you have to calculate those. So the next section just talks about the probability then of getting any of these events. So what's the probability that a faculty member is a full professor and age 40 to 49? Full 156 divided by 1,164. Good. Jessica, what'd you get? Good. 0.13. We could also say 13%. It really just depends on the way the question is being asked, but any of those answers would be fine. I would say, though, reduce the fraction if you're giving a fraction answer. And then number 7, what is the probability that an instructor is over the age of 60? So this is particular to this column right here, instructors. So over the age of 60 would be 0 out of the 33 instructors, since it says instructor. So 0 out of 33, which is 0. And then what is the probability that a full professor is over the age of 30? So over a full professor over the age of 30. So there's a couple ways you could do that. You can add them all together, or you could subtract what? Subtract 2 from the 430. So 428 out of 430. And we get, what do we get? Good. 99.5%. Nearly all are, I should have said here, are age 30 or over. So what is the probability a full professor is age 30 or more? Typo, sorry. And the last 3 are using probability notation. And you'll see more about probability notation in your notes and assignment tomorrow, but the way to read this is the probability of the event A4. And in contingency tables, a lot of times your columns and rows are labeled. So we have A4. This is row A4. So you can see all of the rows are labeled with A in a subscript, and all of the columns are labeled with R in a subscript. And that's pretty standard to see the same variable just with an index that increases as you go. So looking at A3, we have 348. Sorry, it's A4. 253 over 1,164. So 253 out of 1,164. What did you get, Madeline? 11.7%. Nice job. And then the probability of the event A1 and R2. So A1 and R2, the probability of getting an under 30-year-old faculty member that is an associate professor, that'd be 3 out of 1,164. Reed, what'd you get for that one? Gigi, what'd you get for that one? 0.25. 0.025%. So you got 0.0025 as your decimal. Great. And then the probability of R3 and A4, probability of R3 and A4, so that's the 36 out of the 1,164. And for that one, Leanna, what'd you get for that one? 3.1%? So 0.031 or 3.1%. Excellent. I think you have about 5 questions on Math Excel for your assignment tonight.